You are going to see now a demo where we are going to describe the building of a model for abaqus to do the analysis of the impact of a mass on a square cross-section tube. This tutorial is made for the course Instrumentation in the Department of Mechatronics and Mechanical Systems Engineering, University of São Paulo, by Larissa Driemeyer, Marcílio Alves and Rafael Moura. We start with a standard explicit model where we are going to rename to impact of a mass. Okay. And we will create two parts. The first part is the tube itself, which we are going to call tube. Is a 3D modeling, deformable shell structure extrusion. The size we are going to put 200D-3. Just this size is just to create the grids on the screen. We continue, then we create a square cross-section at any position like this. Then you use the dimension tool to give the dimensions to the cross-section tube, say 25E-3 millimeters here, and on this side also 25E-3. Okay, so we do this cross-section done, and the height of the tube, say we do 100E-3 millimeters long. Okay, that's the tube. We created another part, so this is part 1 tube. We create another part which is the impact mass. It's going to be a 3D rigid solid extrusion. The size could be that. Continue. Then we also create a square cross section for that, like this, dimension 2 here. Then we do this dimension a little bit larger than the cross section of the tube, say 30 millimeters, E-3, and here also 30 E-3. Okay, done. And the extrusion we can use 10 E-3, 10 millimeters. Okay, so we have created the two elements that are going to compose our model, and for the impact mass you are going to see that later. It's going to be very helpful to have a reference point. So we go on tools, reference point, and we create a reference point here. On this reference point later we are going to apply the some boundary conditions and initial conditions. Also, it's important to go to this option, select the impact mass, and then we do that. This is going to be useful for when we assemble the model. Assemble means to put the impact mass together with the tube. As for the impact mass, still we can go on engineering features, inertia, create one, and associated this inertia that we are going to create with this reference point, done, and we attributed a mass, say, of 10 kilos. Okay, so that's done for the impact mass. For the tube, we go to for the tube, we create a section, so a shell section, homogeneous, continue, and then we are going to give the value of the cross section of the thickness of the tube, say 1 millimeter. If I press OK, it's going to give an error because we need to define the material this section is made of, which I could do either here or pressing this button here. So I do here, isotropic material, that's going to be steel. The properties for density I'm going to put 7777. For the mechanical properties, elasticity, elastic, I do say 209 gigapascal, 0.28 for the Poisson ratio. Also for plasticity, plastic, yield stress of 555 megapascals, atoplastic strain of 0, so I can add more lines here, but I work with a perfect plastic material, so then that's it for the steel. That's okay now, and then I attributed this section I created to this tube, which is going to change the color now when I attribute this section to green. Now I can go to assembly, and then I do the assembly of the impact mass and the tube. I do out offset, and then I can mesh on the instance, or I can mesh on the part, so like this. Okay. Now I will translate this impact mass to go on the top of the tube, but for that it's useful to create a datum. So then I can go here to move a little bit my model like this, use this option to move it down, and then I go on tools, and then I see datum, and then I created a point midway between 2 points, so I create a datum between this point here and this point here. It's created here, and also I can create a datum between in the bottom of this impact mass, say here, so escape, so in between here and here I created also a datum. Then I close here, then I will select the first point I want to move, this, and I move to here, this. Oh, sorry, I have to select first, translate, I have to select the instance to translate, done. Then the start point and the end point. So that's okay to position the instance, and then I see that's on the top. But it would be better to put a bit higher to be more consistent with any experimental model I can do in the future. So I move a little bit. Now I create also a datum, say between this point, escape. Let's create a datum here, tools, datum. Increase a little bit. So let's create a datum midway between this point and this point. So I created the datum. Okay, and then I translated now this mass, this instance, from here to here. Okay, so then that's done. Let's fit everything in on the screen. Okay, and what I can do now is to we can go bit by bit here. We did part, property, assembly, step. Let's create a step. Let's close this menu, step, create step, dynamic, explicit, continue, and then let's do a description, impact of a mass, impact of a mass, and let's do the analysis during 0.1 physical seconds. That's done. So next thing you have to do is interaction. It's a bit more tricky now, interaction. Let's create the interaction. We are going to create 3 interactions. The first one, general self-contact for the tube not to go inside its on. So self-contact, continue, and then select the surface. So let's move a little bit this way. And actually the impact mass should go a bit higher, né? So let's try, go back again, assembly here, select this, done, 1 point, move to this point, okay. That's done now. Interaction, create, self-contact explicit in step 1, continue. Let's select now this, done. And first let's do the outside of the shell by choosing brown. And I have to add the contact interaction property that I'm going to create here, or like order, or I could create also here. So let's create here, contact, continue, mechanical, tangential behavior, rough, and that's it. Interaction property 1 created. We are going now to create the interaction property 2, self-contact again from the inside of the tube. Okay, so let's move the tube a little bit, escape, select, done. Let's get now the purple, the interaction property 1 we are going to use, okay. And the last interaction, create, is surface to surface contact, continue. One surface is going to be this one, done, brown. And the other surface we are going to choose by node region. So let's move this a little bit, like this. Do a zoom, node region, escape. We are going to select pressing shift here, 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 and here. Okay, done. Finite sliding, kinematic contact, the same interaction property. Okay. So after interaction, we go here, load. The menu of load is where we find the boundary conditions. Let's put this everything on the screen. Boundary conditions, we create encastre, continue. Let's choose the place where we want to put this clumped condition. So it's going to be on the basis, escape. So it's going to be here, shift with the mouse here, here, and here. Done. Encastre. So it's clumped. Let's take the chance to impose some constraint for the reference point, or the impact mass is the same. So let's create another boundary condition here in terms of displacement. Continue. Let's choose the reference point. Done. So U1 0, U2 0, U3 on Z direction we allow to move, no rotations, so okay. And then a third and last boundary condition is the velocity of the impact mass. Velocity, continue. We choose the reference point, done. And the velocity v1, v2 are 0, v3, then we put, say, 1 meter per second. Okay. Now, after load comes mesh. We have two meshes to do. Let's do on the assembly. No, let's do on the part. On the tube first. Let's do it. Oh, sorry, dismiss. We have to do on the assembly now. Let's do this. Select the part. Let's do first the impact mass. Then apply. Let's make a bit larger. Say 0.1 for the impact mass. Apply, no, 0.05. Apply, that should be okay. Okay. Then we do now the mesh. Select the part to be meshed. Done. That's okay, we are happy with that. Let's attribute now to this part the elements. Let's move a little bit here. Yes, escape. Select the region. Everything now done. Discrete rigid element, explicit. Okay. Now let's mesh the tube. So we go on here. This done. Point. Oh no, so escape. Select mesh. In assembly part. No, this is not going to be allowed. Select the instance to be allowed by the global seeds. This one. Done. 0.05. Apply. Okay, let's mesh now. Part to be meshed is this one. Done. Okay. Apply the element. Select the region to be assigned the elements. This one. Done. The element's going to be now explicit, linear, quadratic. These are shell elements. Okay. Boundary conditions are done. Mesh is done. Optimization we skip. The step has been created. So then we only need to go in job, create. Impact of a mass is going to be our model. We called impact. Continue. Okay. And then the job has been created, job impact. We can submit. Okay, we close this. And then we submitted, and after running, we can perform the analysis.